The following video demonstrates how n4ce now supports the direct import of RIEGL RDBX files into the UK grid and datum. Other grid systems or projections are not currently supported. They would need to be exported from Resolve in their appropriate LAS or E57 formats. What we're doing here enables us to go direct from the raw data into n4ce without having to use those intermediary LAS or E57 files. The data has been processed in RIEGL's RiPROCESS software and has been rigorously computed and robustly registered, so all the points are exactly where they should be and are available now for direct import. So using the latest beta, 5th of May, and what I'm going to do is I'm going to go convert to Octree, and I'm going to use this option here that says add folder. Okay, now I have this folder here which contains all the record folders, and all I need to do is just go back and pick the main parent folder, hit select, and it will then import those files, or it will actually search the subfolders within those folders and find the relevant RDBX files. Shows you the current extents, and what I'm going to do is I'm just going to change the output folder because it will default to the first folder. So we'll just go back one, and I'm going to create a new folder in here. And that is where I'll put the root file, and then just press OK. Okay, so I've sped up the system a little bit and we've now imported the data. It's not as quick as importing ordinary LAS or E57 files, unfortunately, because n4ce has to do the reprojection itself. So here we have the test data set. Okay, so hold Control and click. As you can see, all looks very nice and tidy. If I expand the group section, if the data had previously been classified, or if various classifications had been created in Resolve, then they would be preserved here as well. But this data set currently hasn't been classified, so that's why we just say never classified. So I'm going to start by creating my own group called ground data. What I'm going to do is I'm going to use n4ce's group by ground mesh option and create myself or rather move all the ground data into this new ground data group. So I'm going to say, right, my original group is any, target group is ground data, and I'm going to use the general ground preset, but change the service resolution to 0.5 meter. The reason being is that I know that there are some channels here that if I were to use a 1 meter grid, I probably wouldn't pick them up so well. So I'm going to switch it to a 0.5 meter grid so that I pick up more of that information. Show through cloud, and what I'm going to do is I'm going to hit preview. So now n4ce is doing its best to extrapolate the ground data to the lowest levels and create this underlying surfaced model, which we can then use to then group data based on its distance from that surface. Okay, now that that's done, we've got our preliminary ground model. So given that we've got that surface now, I'm then going to say, right, use a distance of say 200 mil, which will allow for a little bit of noise, hopefully. I'm not going to worry about using the vertical distances because obviously we've got some banks in here, so we'll just make it perpendicular to the edges of the triangles instead. And we're going to move that data into our new ground data group. So hit classify. Each point is now being projected onto that surface, and if its distance falls within that tolerance, it'll now be moved into the new group. Okay, now that that's done, if I untick show through cloud and turn off never classified, that just leaves us with the ground data. If I now zoom in, we can take a look at how well that's worked. Okay, so anything that you see that's blue is a kind of above the surface because it's showing through. That appears to have done a very good job. If I quickly turn on the original group but expand that down and say height shaded, and then we do edge enhance, you can see what was left, or rather what's been taken and what's been left. I think on the whole that's done a fairly decent job. Just got rid of those structures there. Obviously you can see the trees have been pulled out nicely, hedgerows have been pulled out. buildings, obviously, they've all been moved or removed. Yep, I think that's done a nice enough job. So I'll just right click to cancel the surfacing mesh tool and turn off the never classified, which leaves us with this. Okay, so what I'm now going to do is I'm now going to create a ground model for that. So to do that, I'm going to go to point cloud IO using the lowest levels, half meter grid with an interpolation set to 0.1 of a meter. I'll just put in 100 millimeters, so it's the same units. So if you can't find a level, it'll go looking at least 100 mil for the lowest one. Align to 0, 0, show to the cloud so we can see it, and remesh over the holes. And let's see what happens. Okie doke. That all looks pretty good. I'll smooth it in the next stage, but as a first pass, I think that looks acceptable. So I'm just going to hit Create Grid and leave it set as they are. Just optimize the diagonals so essentially the contours will line up nicely. Press OK. Okay, so now if I flick back to the project manager, okay, and then view this model. I'm just going to change my contour defaults. So 0.1, let's go 0.25. Okay, and if I just turn off the model, there we go. Now we can see at the moment it's obviously a little bit noisy because we've got grass in here and just the general noise, and it's always inevitable in these types of scans. So first thing I'll do is I'm just going to go to the DTM and come down to smooth. Okay, now that's done, I'm just going to press F5 to update. There you go, you see quite a difference. Obviously I've got these areas in here that I need to tidy up. Because it's a point cloud generated from LiDAR, I don't actually have an aerial image yet. So what I'm going to do is I'm just going to quickly jump back to the point cloud view and generate the aerial image. Okay, so the aerial image is created based on what's visible. So if I wanted the trees turned on, I could just do it like this. You'd see them and they'd be coloured like that. But I don't want to do that for the time being, because then I can't drape it over the surface afterwards. So I'm going to turn them all off. Notice that the LiDAR has obviously seen nicely through the vegetation and the trees to the ground, so that we don't have holes that you might otherwise get with some photogrammetric techniques. So I'm just going to go to Tools, I'm going to go to Export Image, I'm going to say let's have a custom image, and let's have this say 10K, should be nice enough, decent enough resolution. Got quite a lot of memory in this machine, so I'm going to say high usage. Just before I press create, I'm going to just bump up the pixel size to say 4 pixels, so that when I create this high resolution image, we won't see through it in certain places, because at the end of the day it's a point cloud. I'll call it RIEGL Demo, and you need to type to ECW. Now that that's done, if I flick back to the model, I flick back to the model now, move that image over, there we go. Okay, so obviously there's some tidying up to do. So if I turn the model on, you can see we've got triangles in there which we probably don't want. So we can use the tools here to trim those out. So I can just quickly go to points, I'm going to delete by polygon, and in one go, if I just assume it's linear for the time being. There we go, that takes that out. See down here too. So that will hopefully give us a nice model when we look at it in 3D. Okay, so the first thing I'll do, I'm just going to switch it to height shaded. And we'll just expand the shader. So instead of every meter, say every 0.25. There we go. Let's bump up the lighting. Yeah, I think that looks very, very good. Nice clean data, especially when it's compared to photogrammetric data. LiDAR definitely gives much better results. And obviously I can now change the shading again to aerial image and then use the aerial image I just generated. There we go. Nice and clean, ready for volume, sections or any other design work.